So Sean, do you say that
Right.
XTDB 2 will do a copy of whole document when you change one attribute? They don't like do
Yeah,
a triples out of it?
it is a document store. I don't know the implementation details of how that affects it at the Arrow level. But they do emphasize that it is a document store, and you need to think of it that an update changes the entire document.
Okay.
So
Okay. I'm gonna attempt doing this. Well, I guess I should have tried this before.
So who has any visibility in what kind of indices they built for your data? Because they kind of say they will index all of your data, but not read it. I don't think they do it for text fields or like.
yeah, they've talked about
It looks like I need to quit
Lucene.
from Zoom and come back again. So
They've talked
Okay.
about Lucene full text search coming at some point because V1 has it, I believe. So
Yeah, V1
the
has
rest of
some way to plug it, but
yeah, I
it's
haven't
not.
looked at that yet. I haven't gotten far enough in. But yeah, they you do get blanket statements like, "Oh yes, we index everything," and you can query on everything.
Yeah, but
I don't know how that works behind the scenes, but that's kind of quite a claim.
yeah, like for me, just they don't enforce schema. So like, let's say I have integers for most of my fields, and then I throw occasional string. So would it
Is
kill
it
the index or how it works? Like,
is it because is it the EAV nature of it? Do they split it out into EAV
It,
index?
well,
well, they
Arrow,
used to, but I
yeah,
don't think it's
yeah,
for Arrow.
Arrow is columnar, so it's each column has just like data. And so I assume that the reason that they say they index everything is that Arrow lets you index over an entire column. And so you can index on any column in theory, I guess.
Yeah, I think Arrow has some kind of way how it stores it in a sorted way. So it's very quick into like looking and filtering columns.
Is
Hmm.
the can you have nested structures? It's a document, but can
Yes.
we nest things in XTDB?
Yes.
You can nest things. I believe from some of the stuff I've seen on the forums and elsewhere that causes problems for querying on nested
Okay, yeah,
data.
that makes sense. So I'm just guessing, but
Yeah,
like you know how Datomic is EAV, so you got the entity with the entity
right.
ID, and then the attribute, which itself is a thing, and then the value that as it processes documents is its. I'm not just not a statement, it's a question. Are they splitting that up and processing the document and then creating like the attribute? Um,
They do split it. I saw it in their XTDB presentation. So for nested fields, they still built an indices. I don't know how deep it goes, but definitely at least one level for sure. And they also have special processing for sets and vectors. So you will be able to search by values in those sets and vectors. And there is also a way when you do queries, they have this unnest operator
Yeah.
that pretty much like unfolds it into a single column. Like just then you can apply regular SQL or like
that makes sense that it may
XTQL filters.
nesting might have performance issues because it may index, but the return value is the whole string of that value, like a JSON blob or something. And so therefore you can't query into it unless you were to, do some function or something to create another field to extract it out so that it could be
So
indexed.
I'm totally guessing here, but from the way I forgot the name of the architect of XTDB, but he was talking like about that Arrow supports it, kind of. So they just unfold the fields and like this nested thing is supported in Arrow. So they kind of have, like they know that this field is a map, and like then it's like a field, like a map A, and then subfield A1, A2, and so on. So this is kind of on the Arrow side, they like know that this is subcolumn or like whatever they call it. And like it just creates this A1 column, and you can search by these attributes within it. But at the same time, you can probably only search by sub attributes. You cannot really say, hey, do I have a map A with A11 map that like equals? But this is kind of stupid query, so you don't care about it.
Okay, so let's take a quick look at this. And I'm looking at the XTDB hub for V2. And the first thing is what's new in V2. And I guess since we did V1 before, this is probably where we should look at. The hybrid transaction analytic processing. XTDB V1 is mostly targeted towards transactional queries. In V2, we have improved the support for OLAP queries to reduce the need for users to write and maintain ETL processes to a separate OLAP system. As part of this, we are separating storage from compute. Data that is not accessed as often can be kept in significantly cheaper storage. Additionally, data in XT is now stored in the open Apache Arrow format. So I guess we talked about some of these things already. The first class
so the big benefit of it is that now all your nodes, they don't have to read all the data. Like in XT1, you had to kind of replay the whole log from the very start. And it was very painful when you start a new node on the big database. But now you don't have to do it.
And what is it that enables that?
I think it's like they split it into some Apache files, like Arrow files. Arrow supports it.
Okay.
I don't know like how they do it, but yeah, I guess this is something that Arrow does because it's kind of written for that use case.
Okay. And first class SQL support, while we obviously love data log, it's hard to deny the position of SQL in our industry. So all of that stuff has, XTDB has support for two query languages. One is SQL, the other is XTQL. And in order for the two to interoperate, documents in XTDB now live in specific but dynamic tables, the same as you would have in SQL database. But there's no requirement for an upfront schema and no requirement for all the documents in a table to have the same column types or even the same columns. So I guess there's a fair amount of flexibility there. Any comments? Okay.
Well, they invented the new language, XTQL.
Yeah, that's
which
going
is
to be interesting.
Yeah, it looks like Clojure, feels like Clojure on the first side, but I guess they kind of redid all of the functions. There might be dragons flying there, but we'll see.
So the next point is full bitemporality, where XTDB has previously been optimized for point-in-time historical queries. V2 now supports cross-time queries, e.g. temporal joins and temporal range scans. This unlocks the complete history of data for rich analysis. I wasn't quite sure what this entirely meant. If anyone got an example or idea?
So
what a cross-time query is?
Yeah, so V1 was pretty much supported a query, give me all the versions of the document. And that was about it. And V2 supports a query like when this attribute change this thing to this value. Like, so you can kind of, imagine you have a price of some item like an internet store, and you say, hey, at what date the item started to cost $25 instead of like 20 or something. So that's kind of what they mean by it. And I think it also, yeah, like with XT1, you had to like query at point of time. So you're like, okay, give me a database at this time, and then you can query by it. And like here, you can just build a more advanced queries based on like timeline and say, hey, like find in these points of time when something happened in the database.
Thanks. By the way, I forgot to ask you, is the screen, the font big enough, or should I make it bigger? It's cool.
Good for me.
Okay. XTQL, because it just wouldn't be XTDB without having a more data-oriented composable query language. I like the composable part, and I'm at least interested in seeing how it composes. XTQL is inspired by the strong theoretical basis of both data log and relational algebra. These two combine to create a joyful, productive, interactive development experience with the ability to build queries interactively, testing and debugging smaller parts in isolation. XTQL is also amenable to being highly dynamically generated because as an industry, we haven't all spent enough time constructing SQL strings. XTQL also has DML operations, so a lot of use cases that previously required transaction functions for strong consistency can now use XTQL's declarative insert, update, and delete transaction operations. These have full access to the current state of the database. The full query engine can be submitted to the transaction log without pre-registration and are evaluated on the single writer thread. It's available in both JSON and EDN. Eden and other client libraries to come in the near future. So main differences to 1.x tables. Every document now lives in a table. So like a table is a document, or a document is a table?
A table is a collection of documents. So it's much more like traditional SQL databases. You know, you might have a user table and
so like a row is a document?
Subscription table, yeah, and then each row is a document.
Okay. Yeah. Architecturally, the XTDB Golden stores have evolved. The document store is now a shared object store rather than individual documents. This now stores large compacted columnar Apache Arrow index files. It still has a transaction log to impose a total ordering on transactions, but this is no longer required to have infinite. It is no longer required to have infinite retention. The full history is now stored in the object store. The index files that were previously required on every node are now stored in the object store. Each node now maintains a large local cache of its working set, but can fetch missing files from the shared store on demand. Any thoughts, comments?
Well, I have like not super related to this paragraph, but a question that I don't know how to, like, in a columnar database, so you have this kind of long columns of items, and like I imagine that if I have an attribute named A in a table, let's say users, I just have a long column of all of the A values for every row on my table. So imagine I changed for user ID to A attribute to something else, and like, do they put another like record in the table? Do they change it in place and store history somewhere else? Like, how does it like mentally works? Like, I just kind of confused on how they can, like, overall, like all this H tab, I believe they didn't invent it. So like this is kind of what already exists, but I don't know how it works because like last time I was working with big databases, it was like you either, you know, transactional database or your analytical database. It's not like combined.
Yeah, I don't know the answer to that. I know from a SQL point of view, if you're querying things, you could actually treat it as if it was a sort of traditional SQL 2011 temporal database, because you can ask for system time, system from, system to. So from that point of view, they behave just as if they're columns in the database. But I suspect that that's actually computed and all optimized, because if you look at the results that come back, if there is a start date to something, you will have a nil end date. And I know when I've seen some of the presentations, they've shown a kind of grid of times, and things are valid for certain times, and they're in the database system time-wise, so you get these sort of like Tetris maps of data. And the verticals and the horizontals are the two temporal lines. One of them's the system time, when did we know this? And the other one's the valid time, when was it effective from? And I get the impression that a lot of that is calculated, but I don't know the magic source behind how
probably
that's
like
for it to be fast.
They probably merge it in the nodes index. This is my assumption, or like, yeah, just like probably we don't have to be concerned about it that much, but I'm just very curious into how it works.
Yeah, well, hey, it's all open source. You can go read it. But yes.
Okay. The next one is transaction functions are still supported, even though we strongly recommend using XTQL DML where possible. They're now evaluated in a small Clojure interpreter sandbox for security. That's also an interesting thing.
Yeah, I mean,
the sandbox.
With XT1, you had to have specific functions to do atomic operations on data. And that's all essentially gone away. I mean, it's still there, but it's what they've done with the DML and with the SQL side is really opened it up so that doing updates and inserts is so much easier. You delete something and it disappears from system time.
XT1 didn't even have like update field function, so they only had like
you had to write a
put
transaction
operation, so you had to write a function to get me a document, change the field, put it back.
And in 2, you can update fields.
Well, you've got the language to do it. But it still
Yeah,
maintains the entire document is now at that temporal version, even if only one field changed. So how they do it behind the scenes, hard to tell. But given it's columnar, I assume that they don't update it everywhere. They only update it in that one place.
So yeah, like you can just write set version +1. So like you don't have to grab the whole document or anything like that. So just where like ID equals X, set version +1, you're done.
And if you actually then look through valid time or system time, you'll see that you have the whole thing, and then it changes just that one field in the results you get back. So it looks like there is a separate document for every time, even if you're only changing the one field. But it's much more convenient.
At least conceptually, that's how it is, right?
Yeah.
Is that what you're saying? Yeah, okay. Match has been replaced with assert exists, assert not exist, rather than being limited to checking the whole of a single document. These can run any arbitrary query to determine whether the transaction should proceed or not. Okay. I guess when we see some examples, maybe.
That's nice that it's you can run any arbitrary query. It's not just limited to, the row you're working with or something. That may have been the case with one, but I'm used to working with databases where we can basically only enforce on that row. So that's nice and flexible.
rather than supporting arbitrary Clojure functions, queries in XTDB 2 now use an XT standard library of functions drawn from the SQL standard.
Yeah, and those are available
Where?
both in XTQL and SQL.
I was wondering why it was sort of restricted, but maybe that's the reason.
Yeah, and it's also a matter of where you're running the function.
Mm-hmm.
So yeah.
Did 1.0 support arbitrary Clojure functions?
They did.
Yeah.
Okay.
Yeah. In your transaction function stuff, yeah.
So there's not much more on this page, but there is the GitHub page, which has got this diagram here that looked useful.
Is that the V2 branch?
Oh, that's a good question.
Well, the diagram looks correct, right? So they have Kafka log.
They still have Kafka in V1 and V2, yeah. So if you switch
Yeah.
the branch to V2 under master, where you'll see the there, you have to scroll down a bit. There's a lot of docs updates. There it is, 2.x.
Well, I guess it's
different.
different.
There's your new architecture.
So
Cool.
I watched their presentation that they did just before Christmas last night.
Mm-hmm.
And one of the main changes from like developer standpoint, that before you were using mostly in-process API for queries. And now while you still have that same API, similar API, but they recommend using the client driver for any production setup. And this change is because they want to utilize local cache more. So like nodes expected to live longer and use this local cache more.
Yeah, it's because I've been messing about with it on some of my projects. So for example, the user manager example that I often point beginners to, the default has H2 as its database. And I have a feeling it may use a different database for the test than it does for the main. But anyway, I've made an XTDB version of that. And for the tests, it uses the in-process node. And for the regular use, it assumes that you have an external one running. But you can get a local instance running just by doing Docker pull and Docker run. And that's it's a blob of whatever machinery happens on the inside of it. And then you hit it on an HTTP port. Or you can point your app at, Amazon and have a full cluster.
Also, if you use in-process APIs, and you need to have Java above 17.
Yes, that's worth knowing. The HTTP client only requires Java 11. The in-process node requires Java 17.
I see. Okay, so here's, and I hope I've got 2.0 here.
Yep.
Yeah. And I think most of this is just the same. So I think they've got a tutorial for XTQL, which looks like there's a clerk notebook.
Yep.
So I'm going to try to run that. So this is I think this is what you're talking about, Sean, about the Docker container. I think is running that, or is that something?
Have you run the Docker container
Yes.
separately?
Yeah.
Okay. So you've got it running.
I'm not sure actually. It doesn't look like I have Docker running here on my
No.
machine right now.
Okay, so you're going to be using the in-process node.
Okay. So that's this. And then I have, I don't know if people can see this at all, but let's see if I can get. This is the, I'm doing it in Emacs. This is 51071. I'm going to connect to that. And this is the Clojure source of that Clerk notebook.
Mm-hmm.
And I think that should give us something here that I can. So there's that.
I love Clerk. So good.
I'm gonna try and see if I can. Again, is the font size okay?
I can see it very well. I don't know about others.
Maybe make this smaller. Okay, roughly this should work. So I'm going to try and see if I can use this, and then if we need to make any changes, I can go back to the Clojure source and edit it. So this is all this stuff that I just did. We started it up. We have a node, get the status of it. Actually, this was a little bit strange to me because I tried to follow this and it said, latest completed transaction, nil. So I think that's already sort of happened. Because
well, Clerk will evaluate your code when it started. So like we just started a new node a few lines above. So like before the last paragraph. And then it will save the result it returned like the same way REPL will do. And yeah, so that's like they just completed transaction nil, and like they completed a few other transactions as it goes through the notebook.
Yeah, so this has already gone in and populated the database.
Yeah.
So it's got this list here, all the various persons. And
I feel like if you click show code above, will it show us some code?
Oh, okay. Yeah, there it is.
This is what I did.
Yeah. Yeah, and it's up here also on this side if you look at it. All
Oh,
this stuff,
okay, cool.
Yeah. And anyway, all this stuff is done and these transactions are done to load it up. And so now we can really go into, and I think even this is done, this helper function queue, which just does a xt/q and with the my node. So that's there. And queries can be executed. So I'll just try here. And you can see the result there also, but it's also here, I guess. So from movies, movie/title. So makes sense. I didn't really try this one, but I could try this. I see. So now it's giving you a different keyword.
Because SQL can't have slash in keywords, nor
Okay.
dots.
So I think we can skip over the Eden part. So from movies, get movie title, we just saw that. And this was also a good thing that we can take a look at. The movie table has the ID, the title, director, cast, and sequel, and person as ID, person name, birth date, and the death date. So here's a query from persons, find, this is like.
So the first one is similar to equal sign in SQL. So person name equal Ridley Scott. And then the arguments after map is what we should project out of table. So the same that you put in select in SQL.
Cool. And this one is the composability, I presume, here about of XTQL, where you first get the persons, you select the ID. So you get all of them, the name and the ID, and then from there, you do a where.
Yep. Yeah. So this is select from select person name XTID from persons, like in SQL.
Yeah, the composability is nice, which I don't often, I sort of miss in SQL.
Well, I personally like whatever I saw in their presentations more than pure data log. I feel like it's less mental exercise to write this kind of query.
To write this kind of query, yeah?
Yeah.
Yeah.
Because, with data log, you have to do this like kind of pattern matching or something.
Right.
It's like, what is here, like what I named it. It just, for complex queries that involve a few joins, it gets really non-trivial.
Since XTQL is subject to query planning and optimization, these two queries result in equivalent execution plans. If you want to avoid unnecessary processing and returning the person name column in the output relation, return none of the person name key in each result map, we can use a final return operator to restrict the output to a specific set of columns. I see. So instead of returning this whole thing, just sort of selecting out from that. Okay, that makes sense. So here do we want to try and take a guess as to what we want here? Oh, well, I guess the solutions are right below. But from find the title and movies. So from movies, the XTID and movie title. I'm just wondering if it's worth making any changes in the source at all, or should we just go through this directly?
I think it's just very simple, so we can skip it.
Find the name of all the people in the database. So just from persons, get the names, and find the ID of the movies in 1997. So first getting all the IDs and the years, and then filtering out just the movies there, and then returning just the IDs.
And that's one that could just be done with a single from, because you could say from movies and a map where movie year as a keyword matches 1987, and then XTID as a symbol would be the projection.
Great. Are these always on the same table?
No, you wait till you get to some of the later ones.
Okay.
Where you start doing froms across multiple tables and unify them.
Okay. Well, maybe we'll have to, well, let's see how far we can get for today. Relational composition. XTQL provides the rel source operator, which can be used to construct and manipulate a temporary in-memory relation. This relation can be used within a pipeline in the exact same way as a stored relation represented using from. Similarly, columns can be returned explicitly. So that just like creating an inline table, is that, am I reading that correctly?
Yeah, I think so. I had a hard time figuring this out, but I think it's partly to allow you to put kind of your own data into the pipeline. And so you can say, well, here's some data that I've computed. We'll put it into the query, and then we'll get it to unify across all the various things.
Okay. But what is this? Oh, so the foo is the selector at the end.
Yeah, I feel like it just, like from what I see, it's kind of a select key. So if you have like multiple maps with foo, it will be an array, and you can use it in like, oh, if it's in operator or something, SQL. But like they very quickly skimmed over this relational operator, and like I don't really understand its purpose for now.
Yeah, to me, it just looked like it was like putting in a constant, or not necessarily constant because these can be eval, but I think what Sean said is probably the right thing. We can use a star binding to retrieve a nested representation of all columns from the relation. Okay, so instead of selecting, do you know whether you have to have something here, or I guess we must?
Well, I think it's like you have to return something out of it.
Yeah.
So
No,
star is like returning everything, but
okay, yeah. The use of star is rarely appropriate for production queries, but certainly useful while exploring data. Okay, makes sense. Previous query of the subset of the original data. Okay, so yeah, this is just 2 rows from the database, I guess, and just put it in there. But these are not.
I guess this will not go into like, so you just pass it some data you already computed before.
Yeah. So if
and
you've
you
got
can
some
kind of join it with some other tables or whatever you want to do with it. So kind of, yeah, just submit a virtual table or something.
Yeah. So you've got some computed data in memory. And you can say, well, we'll use that in a rel and we'll project out just the following columns out of it, because it might be some big data structure that you've got that's, a sequence of a lot of hash maps, and you're only interested in a couple of columns out of those. And so the rel lets you do that, and then you can unify those columns with other things in the query. So imagine that data block in the square brackets, that's the vector of maps, is some parameter to the query.
Yeah. Do are XTIDs globally unique?
They only have to be unique per table now.
Oh, but now I see. Yeah, because otherwise these are sort of like anonymous tables, right?
Mm.
Well, no, they're not named. Yeah.
I guess they look like tables, like
Yeah.
like a sequence of documents.
Okay. Now I'm just wondering whether this 137 had to be the same as the 137 that was stored in the table in the database.
No. This is computed data that you're putting into the query. I mean, it doesn't even have to have an XTID in, I don't think.
Yeah.
Oh, okay. That makes sense. This query avoids retrieving any of the
Here's a
stored
lot of
data.
examples that don't have it.
Yeah. This query avoids retrieving any of the stored data altogether and is completely disconnected from the person's table. Corresponding XTID within the stored data is unconsequential. Okay, I guess that answers that question. Unnest. Nested values can be accessed as regular columns using the unnest operator, which returns a cross-join relation. I'm afraid I'm not gonna.
So it just unfolded your vector like into my item and made a row for every single one.
It's a bit
So
like a for comprehension for my item in my list. Produce a row.
Oh, but so it sort of adds it to that.
Yeah, just like you now have a single column of my items and you can apply, sum or something on it. Or any other aggregation. Okay.
Using the with operator, which extends the previous relation with additional columns, specific nested values can be accessed using dot and nth operators. What's dot doing?
A field selection.
Oh, I see.
It's a little bit confusing because there's no bar to pull anything. Oh, there's yeah, in this example, my list is a list of maps with a bar key. So dot my item bar will pull out bars.
My item will pull bar bars and
yeah, my item will be the 0th element of the list, and then my val will be the bar element of that. Because they all, the way the pipeline works is each step expands the data or contracts the data. Takes a bit of getting used to.
Yeah. My val. I see. Okay. Yeah.
So in the expanded data below, my list is the whole thing, which is the vector of one element with the map. My item gets added in as the first element of that list, nth of 0. And then my val gets added in as the bar element of my item. So each step refers to the previous step, to data in the previous step.
Yeah. Okay. Unification. Joins in XTQL are most naturally specified using the unify operator. This combines multiple input relations based on the use of logic variables to represent and connect various columns. Within a unified scope, all symbols represent logical variables rather than singular columns. However, a logical variable may take the name of a real column. which creates an implicit binding. Unify provides a declarative and terse method of specifying join conditions, i.e. how relations should be combined with each other. The elements with a unified scope are called clauses. The user-provided clause order is inconsequential, and therefore it is best to arrange clauses for ease of readability and human comprehension. Let's say we want to find out who starred in Lethal Weapon. We will need to process two source relations for this, both movies and persons. And to achieve this, we can embed two from operators within a unify, which itself simply returns a relation. However, this requires introducing our first user-named logic variable here, which we have chosen to be P, and we also need to unnest the stored vector of IDs retrieved as movie cast. So let's see if we... So this returns all the cast IDs, the cast member IDs.
So
And then,
yeah. So movie cast is going to be a sequence of IDs. So from movies, get all the rows that match movie title is Lethal Weapon. And movie cast is a vector or a set. And then we unnest it. So this is the 4P in movie cast. And then from persons, where XTID is P, give me the person name. And at this point, you've got movie cast and P and person name are all the things you'd have in your data. And you only want to return person name. So if you took away the return person name and reran it, you'd see all of the columns that were used in the query.
Right. Logic variables can be reused and referenced as much as required across many clauses within a single unified scope. Think of unification as similar to simultaneous equation in mathematics, a logic variable that connects multiple underlying columns forces the database to solve the query using whatever joins are necessary. Okay, yeah, that's note, an implicit binding will reuse the underlying column name, e.g. movie cast in the from above. The movie cast was a logic variable?
Yes, because it's a symbol, not a keyword. So it happens to match column name. So it basically says, here's a logic variable that's bound to the column movie cast. And you can give those aliases if you want. So instead of saying movie title is Lethal Weapon, you could say movie title is X, as long as X is provided somewhere else.
Okay. Okay, so like you could have a rel which says X. I mean, is that how you do the binding?
Yeah, you could definitely do that. You could pass it in as an argument. We haven't gotten to query arguments yet.
Okay. You could always use an explicit binding map instead. Okay, so that's the binding map, I guess I was thinking.
So
but where did the binding map go?
So that would go instead of the projection of movie cast. So in from movies in the vector, movie cast is essentially shorthand for saying the column movie cast should be bound to the logical variable movie cast. So if you put that map with movie cast C in there,
then
you would then, on the unnest, you would unnest P from C.
Right.
Because that would be the logic variable.
Okay, makes sense. Find movie titles made in 1985. So from movies, okay. This doesn't, yeah, this is what we'd sort of done before.
Mm-hmm. Yeah. Second one is what year was the movie Alien released?
Yeah.
God, 1979. That makes me feel old.
So this is the same from movies, get the movie title, where the movie title is Alien, and then just extract or project the movie year out from there.
Yeah.
And then return that.
So
Why do
return
we
is
need
select keys.
But isn't this doing that?
That's adding the column to the list of things that's being processed. If you ran just the from movies, movie title is Alien, movie year, I think you would get both movie title and movie year. So the return is the select keys that says I only want movie year back from that.
But what does this mean then?
I don't think it will return movie title.
Okay, I wasn't sure. So the movie year is the logic variable that's bound to the column movie year in the database.
So that's a so that argument there is just the bindings.
Yeah.
So this is not a projection, really. I mean, this is not a projection.
It's saying what other things, it's saying what columns you want to come into the data and the aliases. And that's shorthand for a map that's colon movie year to just movie year. And so the logic variable is movie year, but the column is colon movie year.
What happened if you don't have the return movie year? You said you'd get all the
try it and see.
Yeah. Let's see if I can find this thing.
A little bit further down. Yeah, keep scrolling down. There we go. There's the movie Alien year. So yeah, so take the return out and rerun it.
You can just comment the form like that.
Yeah, just
hash pound and underscore before returned.
So it said movie. It said movie.
Yeah. Well, that's
year.
with the return.
So that's
yeah.
Yeah.
So take movie year out of it. Take the return out.
Okay, that.
In answer 2.
But I almost answer 2. Sorry.
Yeah.
But I thought that's what I did.
No.
I mean, I just put an extra parens here and then
Oh.
Yeah.
Okay. So yeah. So Sergey was right that having the column name with the literal doesn't add it to the set. So you would have to explicitly add movie year. So in that case, yeah, return movie year is a bit redundant.
Okay.
Interesting. Yeah, in answer 3, it makes a difference because you're bringing in movie director and person name.
Who directed RoboCop?
Yeah.
So from movies, get RoboCop director, and then from persons, pick up that. Yeah. Okay. Yeah.
And if you had the sequel, it would be, select movie director from movies, join persons on ID equals movie director. Oh, and you'd have to select person name and movie director. and then where movie title is RoboCop. So it all turns inside out.
Yeah. What was 4? Directors who have directed Arnold Schwarzenegger in a movie.
Yeah,
Okay,
this
so
is
that's
nice.
a
It's
lot.
like we're constructing a query and saying, engine, you figure it out.
Yeah. So this is saying find all persons where the person name is Arnold Schwarzenegger and give me the IDs as a logic variable called Arnie.
Mm-hmm.
And then find me the cast and the director from all movies and unify that such that Arnie from the first query is a member of the cast from the second query. And then also find all of the person names for the directors that we found. And then just return the person name. God, that makes my head explode.
Yeah.
What would that even look like in SQL? Yeah. Select person name from persons where. Oh, join movies. Yeah.
So is Unify doing something like a join?
Yeah.
Well, it
Unify
looks like
is
that.
joining. Yeah.
It looks like a join, but we've got the unnest in there as well, right?
So you would have to have a subquery and join across a subquery because unnest is essentially a subquery, a subselect.
Or is
Okay.
it giving us that unnest as a table, right? As a temp table and then joining that unnest into this whole thing?
Well, in this
That's
case,
what
it's
it
kind
looks
of
like.
interesting because although it's for Arnie and movie cast, essentially, which is how I like to think about it, Arnie is the result of a previous query, and movie cast is also the result of a previous query.
Mm-hmm.
So that's unifying across 2 sets of data.
Okay.
That is pretty slick. I bet the sequel for that would be pretty horrendous.
Well, we are at 8 o'clock, or a little past actually. Shall we stop here and resume next time?
I'd be okay with that. I'd be okay with going on, but I'm also okay with stopping.
Okay.
Yeah, I have to go, so
Yeah.
thanks everyone.
Thank you,
Okay.
Sergi.
Yeah.
Bye.
Bye.
Yeah, it's great to see you all. Thanks for walking us through this.
Yeah.